name is Yingda Li. Today I'm going to introduce my research paper. Its name is Autonomous Climbing Robot Design. First of all, I'm going to give an introduction of my research paper and introduction of robot. In fact, humans just regard robots as a kind of important tools. The robot can help human beings to deal with a lot of problems, especially in some high-risk fields such as work in nuclear facilities. And the development of robots can help people, can develop the robot can replace human beings and help human beings in this kind of area or field. It's also a trend of the developing more advanced robots in the world recently. Since there are numerous research studies are shown on the Gross Scholars and the library database, there are a lot of research studies there, and the number is still increasing. It means there are a lot of and more scientists and researchers are interested in these topics. For me, I'm going to focus on the climbing robot, since a multiple function climbing robots, which can fulfill with multiple tasks, is very useful to accomplish many tasks for human beings. My research question is, how can an advanced autonomous climbing robot be developed? So for that reason, I think I need to combine the mobile mechanisms and bioinspired materials together, which means combine these two technologies together enables a robot can move both vertically and horizontally. And besides, I'm going to compare several robots in the method section. I will compare their mobile capabilities and adhere capabilities. And why the reason why I interested in this topic is because first of all, I major in mechanical engineering, and the robot topic is related to my major. And I also have a course called robotics just in my major. Secondly, I feel proud of my major, since the major is contributing to human societies and to contribute their life, to help us to have a better life. Thirdly, that's the first time I have a chance to do real research. Not that real, but it's a research, and I combine and synthesize several articles and research papers together and try to figure out what's going on. Yeah, so I'm interested in this topic. The second section is the literary review. I will introduce several article research that I did. The first one, the title is Development of Robotics. The author introduced a theory. It's about the 3 generations of robotics. Since the author believed there are 3 generations of the development of robotics. The first generation is a semi-automatic robot. In this step, the robots are still stay in mechanical arms and stay in factories, help human beings for the mass production, and it still need to be controlled by human beings. And the second step is the robots which can fulfill and accomplish certain tasks, and the third generation is the robots with the intelligent brains. They can cooperate with human beings automatically, and they can even learn something and learn some new skills by their own experience. They also introduced trends and the gaps of the development of robotics. In fact, the scientists now are followed in the several aspects to achieve the third generation. They follow the cloud robots, the humanoid robots, the bio-inspired, and the mobile robots. Those are several aspects. And according to the authors, we still need several decades to achieve the third generation. So it means now we are staying in the second steps. For me, for my research, I'm going to discuss the climbing robots. Since I want to focus on some specific purpose of robots, and for my robots, I think it can. I want to combine the mobile capability and bio-inspired material together, and to approach the third generation. The second research paper is talk about a specific project. It talk about robot called a self-loading robot. It's just like the picture. It's a bio-inspired and a versatile robot, and it has the biomaterial on its legs. It can adhere on the wall. This robot has a feature called self-cleaning feature, and this feature provides it a capability to adapt to the rough surfaces. The rough surfaces like the wall are not like the glass. Besides, this robot can be driven by the electronic system and with batteries. I think these robots, in this research, the author haven't discussed about the superiorities compared with previous research, and the author also didn't discuss the comparison with two kinds of surfaces, both smooth surfaces or the rough surfaces. The author only discussed the rough surfaces. Another research is talk about a robot called the Mini Wings. This robot also inspired by a kind of insect, and it has the bio-inspired polymer material, just like this, and it enables this robot has almost three times pull of force per unit. It means it can adhere on the wall better. Besides this robot, the biomechanisms can be transferred to the artificial mechanisms. It's the important point for this robot, since the scientists find that they can produce this kind of material and apply this material to other robots. So that's a big contribution in this field. However, for this robot, the author only discussed the situation on the flat surfaces, but they validated this robot in the flat surfaces, but they haven't discussed about some uneven surfaces and in some irregular situations. Sorry for this. Another robot called Asgard, just like the picture showed. It has the body axial structures. This structure provides this robot have a higher traction with the ground. Besides, it has the four-spoked wheel like this. This structure, this four-spoke wheel structure, provides this robot have the capability to climb over the obstacles and even the stair. More important, this robot has the weighting capacity. There are seldom research studies talked about a robot have both capability in water and on ground. But every research have their limitation for this robot. The limitation is the robot can only negotiate with the obstacles with the height much lower than the shaft of this wheel. It means the wheel like this big, it cannot negotiate it with the obstacles higher than the shaft of the wheel. The last robot called MicBot, I think it's a fancy structure like a tech. It has the 4-track module structure, like four legs. Besides, it has the clutch mechanism. The clutch mechanism provides this robot the capability to shift the meshes of the gears and to go straight, go forward and backward, just like our cars. More importantly, it has the self-rescue system, which include 2 arms. These 2 arms can be driven by this recurrent motor. When it falls down from the stair and the back hits the ground, the 2 arms can put up the body and turn it over, and to help it to reposition itself. But it also has the limitation is because it can only negotiate with the obstacles. The size is smaller than the track. Yeah. For that reason, several research methods are developed. The aim is to find out the most efficient structures and the most effective adhesive materials. I'm going to test above-mentioned robots, include the self-loading robots, mini-wig, MacBot, and S-Guard, to test their mobile capabilities and to test their capability of the bio-inspired materials. The first research method is to test the speed of all these robots in horizontal situations. The horizontal situation include the flat surface with wood, glass, cement, and sand surface. The parameters are limited. I need to design a certain distance and for their travel, and they are required in the same weight and the same maximum output power of motors. A chart was designed for the first method. It's on a certain surface on the cement road, and the distance, several certain distance, 100 centimeters until 1,000 centimeters, and all of these robots are tested, and I will record the time in the chart. The second research method is to test the speed in an uneven situation. The uneven situation means the surface uneven on rocks and even in forest. The parameters also are limited, the same thing as the first one. A certain distance, 5,000 centimeters, and all these robots are tested, and the surface on the forest, and record the time of these robots. The third method is to test the climbing capability on stairs. Since they can climb over several kind of obstacles, include stairs. Since the stairs is the main purpose, one of the main purpose of the scientists focus on this field, like the wheelchair. If we can overcome these problems, the patients with the wheelchair can go up with the stairs. I designed for it's called the wise height ratio of the stair. If the ratio is 2, means 40 centimeters weight and 20 meters height. So it's a ratio for the stairs, a different situation, and to record the time into the chart to compare those robots. And the first method of the research is to test the speed in vertical situation. Since there are only 2 robots have the capability of climbing on the wall, so only test the number 2 and number 3 robot. I will test them on several surfaces, including wood, glass, and cement. And the parameters are limited. They need to have the same weight, same maximum output power of motors, and the same amount of adhesive and the same adhesive area material per unit. It's the chart for method 4. They need to climb 200 centimeters on the wall, and those two robots are tested. For future study, I believe we still need to develop some new mechanisms for robots. Until now, we have several kinds of mechanisms like the track modules, the wheel, spoke wheel, pedals. So I think there are some new mechanisms need to be developed. Besides, we need to develop some new bio-inspired materials. Those materials are inspired by geckos, spiders, or other insects, and I think we need to find more materials. Besides, we need to validate this material and mechanism in several specific analysis, such as the dynamic and the static analysis, to validate whether it can be successful. Finally, we need to do more extensive experiments to make this model in different sizes and to apply it for the market, and we can produce this kind of robot. And that's a reference. And thank you.
What is the purpose of this robot?
What do you mean? Those?
The main purpose.
The main purpose is to find the most efficient structures and the most effective adhesive materials of the above-mentioned robots.
So then would your goal be to recombine those structures, maybe structures or adhesives from different robots into one new robot?
Yes, I'm going to figure out which are the best structures and the best materials, and I will combine them together into a new robot. That's my robot, and can fulfill more tasks.
What kind of tasks do you want to do?
In fact, I still focus on the climbing. Since none of those robots can fulfill the function both in ground and vertical situation. So we need a robot can into some place and move vertically and horizontally.
So I had a question about your method. I know you said that the robots need to have the same weight and the same power.
Yes.
So the parameters for the studies will be the same. As those robots have been designed now by other researchers, are they the same, or will you have to rebuild and redesign them so that they'll have the same weight and same power?
In fact, they must don't have the same power output, but I have to design a model to limit they have the maximum output to be fair. So I cannot have a robot with a lot of motors and another robot only have one motor. So like that. Any questions?
Do you have any idea about any prediction about which of the robots you think will perform the best on your tests? One that you like the most?
To be honest, I prefer this one.
Okay.
Since I believe the track model is useful for more situations compared with other spoke wheel or pedal structures, and the bio-inspired materials can be adhered on this kind of structure easily.
Have you taken a robotics class before?
No. Almost.
Thank you. Great.
Thank you.